X marks the spot. Right. Oh, I'm just going to move my cursor off the screen just in case it was just showing. I'm going to talk about something called Wardley mapping, something which I created, gosh, back in 2005. It's almost 20 years old now. God, it feels a bit aged, a bit like myself. I'm going to talk about the origin of Wardley mapping, how I got into maps. Then I'm going to talk about patterns that we discover from maps. Then I'm going to talk about change, so how we look at change through the lens of mapping. And then I'm going to talk a little bit about gameplay, so how you could use maps to change the environment you're in. And finally, I'm going to talk about X marks the spot, which is a bit about investment. And I'm going to primarily focus on AI. So I'm going to use all of this stuff to give a particular view of what is going on in the AI space. We've got an hour to do this. All right, so the origin. So it all starts with this company back in 2004, roughly 2005. It was an online photo service, 16 different lines of business, very profitable, but it had a huge problem. The problem this company had was this person, the CEO. Our CEO was completely clueless. They were making stuff up as they went along. They had no idea what they were doing. And I know this because I was the CEO. I used to come out with these wonderful vision statements about how we would be open source and agile and all the rest of it. This was back in, oh gosh, 2003, 2004. But literally, I'd pinched those from other companies, just changed a few words. I had no concept of what to do with strategy. I used to read all the strategy books I could find. It's getting nowhere. And then I ended up in a bookshop in London, and I was talking to the bookseller, and she asked me, had I ever read Sun Tzu's The Art of War? To which I said no. And being a good bookseller, she persuaded me to buy 2 different versions of the book because they're all translations. And I'm forever grateful for this, because it was in reading the second translation that I noticed a particular pattern. So Sun Tzu talked about 5 factors that mattered in competition. Now, when we talk about competition, competition is the act of groups seeking something, like a resource or whatever. There are many different forms of competition. You can seek through conflict, fighting others. So conflict is a form of competition. You can seek through working with others. So collaboration is a form of competition. You can seek through helping others. So cooperation is another form of competition. All right. So the first thing you have to worry about is purpose. What's my moral imperative to whatever I'm doing? The next 2 things you need to be concerned with, or 2 factors, are the landscape itself that you're operating in and how the landscape is changing, or the heavens, the weather, or climate. The next factor is doctrine. So these are the principles by which you govern your organization, the rules. Well, they're not rules, actually, they're principles in this case. And the last one is leadership. So this is where we get into gameplay and how we manipulate a space to our favor. So 5 factors matter. Have a purpose, a moral imperative, understand your landscape, understand how the landscape is changing, the climate, understand your principles of organization, and then you get into the whole area of gameplay. And for me, I was fascinated by this. It sort of made sense. And then I came across John Boyd, the Mad Major, who created the OODA loop. So the OODA loop, used in both military and political circles, starts with observe. That's what landscape and climatic patterns are about. Orientate yourself around the space. That's what principles are about. And decide where you're going to act, and then act. And they overlap beautifully. So for me, this sort of became my sort of first understanding of what I might need to be doing with strategy. And I got really fascinated by how do I observe the landscape. And that's what got me into maps. So I started looking into all sorts of maps, military history. One of my favorite battles is this particular battle, the Battle of Thermopylae. So maps have been used in military to learn about how to mostly conflict with others, but there are other forms of maps as well. And they learn from one battle to another. And there are major forms of communication. And you see this in films because you often have the general with a map, and then senior officers with a map, and then the troops on the ground with a map. And of course, I was looking at my organization, and we had like all sorts of wonderful artifacts in the boardroom, and then including things like SWOT diagrams, and income statements, balance sheets, lots of business cases. And then lower down the organization, we get into Gantt charts and things like that. You use those, well, you still in some places, and right down with things like systems maps. And so we were using completely different vehicles to communicate about space, and we were wondering why we had business alignment issues. And it was just like, well, I'm surprised if we didn't have business alignment issues, we're not actually going to communicate with a common language. So I got really interested into the use of maps, and this is the Battle of Thermopylae. So the Persians are invading, 140,000 Persians. Themistocles, ancient politician, Greek general, decides to block off the Straits of Artemisium, force the Persians along a coastal road into a narrow pass where a small number of troops could defend against a larger force. There were about, as I said, about 140,000 Persians. There are about 4,000 Greeks in the army, including 300 Spartans. And this is where we get the story of the 300. And so I started to think, well, how would I make decisions about this space? Because I can see you've got choices, defend around Thebes, Athens, and you can see how we could use this to communicate to others what we're doing. Well, I was using things like SWOTs. So I decided to create a SWOT of that battle. Strengths, a well-trained Spartan army, a high level of motivation not to become a Persian slave. Weaknesses, the E4s might stop the Spartans turning up. A truckload of Persians are turning up. Opportunities, get rid of the Persians, get rid of the Spartans. We're Athenian, actually. We hate the Spartans. And the threats, the Persians get rid of us. And the Oracle says a really dodgy film might be produced a few thousand years later. And I just put them next to each other and ask the question, what would you use to communicate and determine strategy in battle? Position and movement described in a sort of map or a magic framework like a SWOT. And it was just like, well, that's obvious. So the next question is, what was I using? Well, I was using the magic framework. So at that point, I said to everybody, right, I need to see our maps. And people sent me loads of maps. They sent me mind maps, business process maps, systems maps, lots of different maps. I was quite excited by this. And I picked up one of the systems maps, and this is for an online photo service. I took one of the components, I put it in gray, customer relationship management, shaded in the entire box. And then what I did is I moved it. I went from there to there. And I asked, how has the map changed? And the answer is, well, it hasn't. And that's really odd, because if I take a geographic map and I don't know, I take Australia and shift it next to Berlin, for example, that would be a major change to that map. Why is this map not changing? Well, all of these maps had one thing in common. None of them were maps. They were all graphs. So to explain the difference, these are three graphs, the images at the top. They're all identical. There are three places, Nottingham, London, Dover, connected by two roads, M1, M2. And they are identical graphs. Now, the images at the bottom are completely different maps. Nottingham, London, Dover, connected by two roads, M1, M2. So the difference between a graph and a map is, in a map, space has meaning. And that's because you're mapping a landscape. So with a graph, I can just turn the graph 90 degrees, 180 degrees, it's still the same graph. But with a map, you can't. So where does this space having meaning come from? Well, you need three attributes, basically. You need an anchor, such as magnetic north. You need position of pieces. This is north, south, east, or west of this. And you need consistency of movement. If you've got those, you can describe a landscape, which is what maps are good for. So I decided to map my own business. Now, as I said, this was back in 2005. A photo service, very boring, so I thought I'd do a simple example, a tea shop. So how would you map a tea shop? Well, first we need anchors, such as public and business. So that's what we're going to focus around. Hopefully the public wants cups of tea and the business needs to sell cups of tea. Great, that's a starting point. Now, a cup of tea has needs. It needs a cup, it needs tea, it needs hot water needs cold water, a kettle needs power. So what you've got are anchors and position described through a chain of needs. Now, this is a graph at the moment. We want to turn that into a map. And it turns out that all of these are forms of capital, and all of those forms of capital evolve through a common set of stages. You start off with the genesis of novel and new when you're talking about physical activities, custom built examples, products and rental services, and then commodity and utility services. So all I have to do is go through and say, is this more of a commodity, more of a product, more, something which doesn't exist in the market, so I have to custom build it. And so therefore I can describe a map. And now I've got anchor, position, and movement. Now, what I'm really doing is I'm exposing my assumptions to you about how I think a tea shop should be. And you might look at my map and go, well, you're missing staff. Or you might go, there's no payment mechanism. Or some of you might go, why have you got kettle and custom built? Right. One of the things I found with my organization was that we were running with stories. And the problem is we tell people that great leaders are great storytellers. And that creates a problem because when you challenge somebody's story, you're actually challenging their leadership ability. You're saying you're not really a great leader. And that's why people get defensive. One of the things about putting that story in a map is I can challenge the map without challenging the person. So I'm not going, oh, you're terrible. I'm going, I think the map is wrong. And so one of the things we find with maps is you can use them, expose your assumptions, and allow other people to safely challenge them. And so we can ask that question, why is the kettle custom built? Now, these sorts of maps, I mean, that's a very simple example. Somewhat more complicated maps, we map, I map industries, even nation states. We had one particular project, UK government, I did a lot of mapping, helped a lot of people do mapping there. One project alone saved about 425 million, about 1.5 billion in its lifetime. But it's not just like government and commercial, all the way into space. NASA and Planet, with their carbon mapper satellite, they actually work with multiple groups and use Wardley maps in the background to communicate. So I thought I'd give you an example just to show you about this importance of challenge. This is an insurance company. This is back in 2010. Very simple. They need, this is their basically business process flow for putting compute into a data center. They'd order compute, the service would arrive, going the goods in, then modify, mount, and rack it. There was a bottleneck in their process flow to do with the modification mounting. And so they put a team together to look at this bottleneck, get rid of it. They spent about 6 months working on this, wonderful business cases, return investment calculations, all that sort of stuff done. And they're about to spend millions on this. And I was asked to have a look. Now, the problem is I can't go in there and say, why are you doing robots? That's their story they built up. Who am I just coming in from the outside, challenging their story? So I said, could we map this? And they were very resistant, but after about 15 minutes, they decided, all right, we'll give it a go. And they took 15 minutes to map it. And this is their map. User needs compute. They put compute in product, order server goods in. Very much thought of those as very commodity-like things. You can map not just physical activities, but practices, data, knowledge, even ethical values. We just have slightly different labels for the 4 different stages. And then they went rack, mount, modify. And I was able to look at this map and go, why have you got rack and custom built? Turns out they had custom built racks. Right, what are the modifications you're doing to service? Well, they don't fit our racks, so we take cases off, drill new holes, add new plates. And that's why you need robotics, yes. And somebody in the room just went, hang on, why are we using standard racks? Then we don't have to do any of that. Now, these people weren't daft. What it was is at some point in the past, there were no such thing as standard racks. And so they built their own and got a company actually to build their racks. And they built this had become part of what they did. It became part of the story. They kept on continuing with this, just finding ways of making it more efficient. They had no means of actually challenging what they were doing. So these people weren't daft. What they were doing is they were concentrating on improving process flow, which is the blue line, rather than thinking about evolutionary flow and how things had changed. And of course, as soon as they realized this, um, well, actually, the next step, they said, well, why have we got computer products? It's more of a utility. Why are we messing around with data centers and robotics? And they started using cloud instead. It was the obvious thing to do. Now, one of the things about maps is I use them a lot to learn patterns, and we do this through pre-mortem, post-mortem. So before we do something, we create a map and we challenge what we're going to do. And the process of creating maps is for an hour, maybe two. I mean, something complex like a nation state or an industry could take a day, maybe two. But most maps are done pretty quickly. So we do we create a map of the space, we challenge what we're going to do, and then we go and do it. And then afterwards, we come back and we look at what happened and what the map said. And from that, we learn patterns, which is my next topic. Patterns. I'm going to use another example because I like examples. This is HS2 high-speed rail, big heavy engineering project. This is James Finley, CIO of former CIO of HS2. And his problem was they needed to build the railway in a virtual world. And the reason for building it in a virtual world is it's cheaper to dig up a virtual world and go, whoops, we've got that wrong, than it is the English countryside. So this is a systems graph for building HS2 in a virtual world, and it's from about 2012. There's a whole bunch of words I don't actually know the meaning of, but there we are. Now, James's problem was we normally broke this into small contracts in government and would outsource them as lots, and these would invariably lead to massive cost overruns. Well, that's what the history was. And so James didn't want to do that. James wanted, is there a better way of actually managing this? And so what he did is he spent Sunday afternoon, and he's an old friend of mine. I taught him to map a long time ago. And so he mapped it out, and he sent me the map and said, look, this is what we're trying to build. How do you manage this? Now, this stuff was fairly easy for me because, as I said, I started mapping in 2005. Beforehand, we'd gone all agile extreme programming in the I happened to know Ken Beck. And of course, by about 2004, we realized it didn't work everywhere. And we couldn't explain why until we had maps. And so it was very easy for me to bring those lessons here. So when you look at a map, it's not static. Everything's evolving from this uncharted space on the left to very industrialized on the right. So you start, it doesn't matter, money, computing, penicillin, all starts in this sort of Genesis custom build, eventually gets commodity-like. And as it evolves, its characteristics change. And for that reason alone, there's no such thing as a one-size-fits-all method. Agile extreme programming is very good on the left-hand side, because that's where you need to, reduce the cost of change because change is the norm. But on the right-hand side, Six Sigma outsourcing, all those sort of waterfall things we dismiss, even though no one actually uses waterfall, they're very good because they reduce deviation. And for a commodity, you don't want things to change. In the middle, you're all about learning and reducing waste. So everything evolves is moving through different methods. So if you take that and take a map at a moment in time and just apply that, then what you see is on the left-hand side, you want to do build in-house with agile techniques. In the middle, you want to use off-the-shelf products, lean. Right-hand side, you want to outsource to utility providers. So rather than breaking it into lots and using outsource everywhere and thinking that just breaking it into small components will save you, the obvious thing is to use appropriate methods, which is what James did. And as a result of which, this project ended up in front of the Public Accounts Committee because it was delivered way ahead of schedule and way under budget. Now let me go back and think about those contracts, because we talk a lot about, oh, we've got to use agile everywhere. But remember, there's a difference between using agile, like extreme programming, and being agile, which is using appropriate methods. So if you're, agile building a house, you're still going to use bricks. You're still going to use standard pipework and everything else. Well, if you actually want to get it completed on time. So let's go back and have a look at the contracts. This was lot one engineering, different components. We're going to outsource it all. There's not a lot I can say about whether it's going to succeed or not here. But if I now overlay that on a map, I can tell you this contract's going to fail before we've written the paperwork. And the reason why it's going to fail is that some parts will be efficiently treated because they are very commodity-like, can be defined. So you can write them in a contract. That's the bits on the right. But the bits on the left, we're still learning about, or they're constantly changing. So we're always going to incur excessive change control costs if we try and stick them in a contract. Now, this approach of using appropriate methods is just one of many principles that you learn, or the collection of which we call doctrine. There's 40 of them. So there's things like focus on user needs, understand your supply chain, have a common language, challenge your assumptions, use appropriate methods. I mean, this stuff is really, really basic, but most companies don't use it. And when I say most companies don't use it, you've all probably worked for companies who don't actually understand who their users or what their user needs are, who don't understand the supply chain of their companies, who don't actually challenge assumptions, who don't use appropriate methods. I would imagine most of you have worked in organizations like that. This is really basic stuff. But of course leads to the question, how does anybody survive if they get all this basic stuff wrong? Well, you only have to be as good as the next person. So if everybody sucks, it's fine. I mean, as long as we're all hopeless. So the next set of patterns I'm going to talk about are climatic patterns. These are, you don't get a choice about these. These are like the economic rules of the game, but they are useful for anticipation of change. So to explain what I mean, this is roughly 2004, 2005. A very simple map of computing. User needs an application built on best coding practice on a runtime like LAMP or .NET back then, on an operating system on best architectural practice on computers as a product. I use a lot of technological examples here because, well, cloud is a nice, interesting change, and I said I would talk about AI. I mean, a lot of my stuff is things like healthcare and defense, and all agriculture and all sorts of weird and wonderful spaces. But anyway, this is roughly compute 2005. The first pattern you learn, or climatic pattern, is everything evolves. If there's supply and demand competition, things move from left to right. And many of us were anticipating the creation of utility compute. I thought it was going to be Google. It turned out it was Amazon AWS in 2006 with EC2, just prior to that, S3. So everything evolves. It's all moving from left to right. Now, one of the things that happens, and the second pattern you learn, is past success breeds inertia. So as things evolve, we have inertia to that change caused by pre-existing capital, pre-existing practices, pre-existing ways of operating, basically. So when cloud appeared, if you had lots of data centers and you were very good at that, you were probably very dismissive of the space. The next pattern you learn is you get co-evolution of practice with the underlying change. So as compute moved from more of a product to more of a utility, a key characteristic was known as mean time to recovery. So that went from, it used to take weeks to get a new machine, it now took seconds. So all our architectural practices changed, and we no longer focused on scaling up and N+1. We could distribute systems designed for failure, all this sort of wonderful stuff. And so what you get is a new emerging practice. We didn't know what it was going to be called. Andy and Patrick, I think it was about 2009, 2010, roughly sometime around then, called it DevOps. The next pattern you learn is that as things evolve and they become more efficient, they enable innovation. So they enable us to explore, well, we call it adjacent possibilities. So it's easier to build new things with standard components, for example. And you saw that with cloud. As things evolved, you got a whole bunch of new things being created much more quickly and, of course, much more efficiently. And those higher order systems create new sources of value and worth. So things like Netflix. One of the things people often compare Netflix with Blockbuster. It's an interesting one. They say, oh, don't be like Blockbuster, a dinosaur like Blockbuster. Blockbuster was first of the two with a website, first with video ordering and online, and first with video streaming experiments. The problem with Blockbuster, it had inertia created by its pre-existing business model. So it made most of its money from something called late fees, so people forgetting to bring videos back, and that requires physical stores. So Blockbuster didn't go to the wall because it was lacked innovation. It was because of inertia. All right. So those are some very basic patterns. Things evolve. You get inertia because of pre-existing business. They enable new practices, new systems, new higher order systems, create new sources of value of worth. There's about 30 of those. I've just shown you a handful, all right? And one of them is you have no choice over this evolution. So if you're competing against others and they get access to new sources of value, efficiency, and speed, it creates pressure on you to adapt. As more evolve, that pressure on you mounts. That's known as the Red Queen, Van Valen's Red Queen effect. So from the point of view of investing, the map was useful back in 2008 because I could see where I should invest, emerging practice, new needs. Of course, I'm simplifying it here, and where not to invest. I didn't want to invest in all that best architectural practice stuff around computers, product, service. Now, my interest in investment is a friend of mine's, Mark Shuttleworth, runs a company called Canonical. I joined him in 2008 to run strategy and to take them into the cloud. And we provided Ubuntu. We were about 3% of the operating system market against Red Hat and Microsoft. They had all the money, all the people, all the resources, everything else. We were tiny, but we had a map, a little bit more complicated than this one. We used it to attack the market. In 18 months, we went from about 3% of the operating system market to 70% of all cloud computing. So if you were involved in technology in those spaces, you suddenly saw Ubuntu was everywhere. It dominated cloud. Okay, well, you were mapped. Right. So a couple of things we knew were you had no choice because of Red Queen effect. New practices would emerge, for example, DevOps. We didn't know it was going to be called DevOps. It was about efficiency. There'd be no reduction in IT budget. That's known as Jevons Paradox. So I used to get all these consultants running around saying, cloud, it's going to save you money. You're going to reduce your IT budgets. The answer is no, because you just do more stuff. You're in competition with others. No reduction in staff numbers. Again, loads of consultants running around saying, oh, look, cloud is going to get rid of all your staff. You won't need them, no, because you're going to do vastly more stuff. You're actually going to need them. If you get rid of them, you're going to have to hire them back and it costs you even more. And of course, an increase in energy consumption. Right, by 2010, the emerging practice had a name, DevOps, and the runtime. So this is like lamp.net. So this is the place where you code. So you write your code and there's a runtime it runs in. That had moved, it evolved, to become more of a commodity, and it was called serverless. Exactly the same pattern. Inertia to change because of pre-existing practices. Of course, it's about efficiency and speed created by a new set of practices which we hadn't given a name for. And enabling new needs as well. So it's exactly the same pattern. So if you're investing, 2016, you're now investing in those spaces. Okay, and of course, you're not investing now in the things stuck behind the inertia barriers. Now that's 2016. So things like DevOps and even cloud infrastructure were becoming the new legacy. So the point about this is your strategy is iterative, it's transient. where you attack a market in 2008 is not going to be the same as where you attack in 2016. 2008, you're all about DevOps and cloud. Early to the game, yeah, loads of people, lots of inertia. Oh, it's not going to be a big thing. They don't understand the basic patterns. Loads of consultants giving you bad advice. Cool, fantastic. 2016, exactly the same play. And yes, you had no choice. New practices would develop. It's about efficiency. Those practices eventually got called FinOps. We're still going through that at the moment. Yes, loads of consultants saying it's going to reduce your IT, but no, it's not. You're just going to do more stuff. You can get rid of staff numbers. No, you're going to need to do more stuff. If you get rid of them, you're going to have to hire them back. It's going to cost you more money, increase in energy consumption. You can read all about that in the Flywheel Effect. A wonderful book, by the way. I'm just going to go back by Dave Anderson. It's about the journey of an insurance company into serverless. All right, let's quickly talk about play. So I said there's about 40 principles, which are doctrine, universally useful. A lot of organizations fairly oblivious to this stuff. There's about 30 climactic patterns we know. All of this stuff is Creative Commons, by the way, help yourself. That's useful for understanding and anticipating change in the market. There's over 100 different forms of gameplay, which are all context specific. And so I'm not going to go through 100 different forms of gameplay. I'll show you one. And it's a very simple model called Innovate-Leverage-Commoditize. So what you do is you take a product and you turn it into a utility. So this is a model I wrote about back in 2005. You turn it into a utility, you expose it through an API, and you allow other people to build on top. Now, why would you do this? Well, let's say we take compute. We turn compute into a utility. We enable other people to build on top. Well, we can charge them for the service, and we make their life easier because they don't have to worry about installing compute and blah. They can just call it through your API. But we can also mine our metadata. So if lots of people are building on top of us, we can see who's becoming successful because we're billing them. Of course, we are allowed to look at our own billing data. We don't have to look at their data. We just look at our billing data. So we can identify new patterns and we can use that to say, oh, this industry is growing. Maybe we should build a component service in there. So lots of people using our, say, mythical compute as a service. Lots of people building kit and internet going nowhere. Several people doing something called big data, rapidly growing. All right, we better come out with a new component service for big data. We'll call it, I don't know, Elastic Map Reduce. Everybody in the industry cheers because now they can do big data stuff, except for the ones who are building a business in that space. They go, you've eaten my business model. So we're just repeating this pattern now of allowing people to build on the top of that and mining the metadata. So what's actually happening is you're getting everybody else to innovate for you. You're mining the metadata to spot future patterns, which you're commoditizing to component services. So leveraging the ecosystem to spot that which you commoditize. And the reason why you would do this is your apparent rate of innovation, customer focus, and efficiency will now all increase with the size of the ecosystem. So as you get bigger, your ecosystem gets bigger, your rate of innovation, customer focus, efficiency all go up. There was an old piece of work which basically said you could only do one or two of those things. This is why I wrote this model in 2005 to show you it was very easy to do all three. You can read about it in this book, Reaching Cloud Velocity. AWS publishes a few of its own books, so by its own people. This is Reaching Cloud Velocity. It has about 17 pages of my mapping in there, including the whole ILC model. And it's a very easy way of tearing up industry after industry. I mean, there's ways of defending against it if you know what you're doing, but most people are fairly oblivious to the map anyway. And so the typical way you would use it, and this was from a talk I gave in 2018, where we were also talking about machine learning, you'd build the ecosystem around compute, and then you'd move up the stack in various different directions. So you might go, for example, through machine learning engines, machine learning platforms, discrete services, AI services, etc. And that brings me on to the final topic of today, which is X marks the spot. And more importantly, a discussion about the AI space. All right, So in 20 years, other things being equal, most of the routine professional tasks will be done by intelligent machines. That is a terrifying, scary proposition, particularly since it was written in 1962. Donald Michael's Cybernation, The Silent Conquest. Jeremiah Hawkins in 1896, in the New Catechisms of Electricity, discussed how within about 30 years, there was a set time period, there would be mass unemployment by the introduction of electricity, as there was no jobs for people to do. Of course, whilst it's very easy to see what is going away, it's very difficult to see what is coming. So there's no point going up to a gas lamp lighter and saying, oh, electricity is going to put you out of a job, but don't worry, you could be a radio operator, because people will go, what's a radio? Equally, in Donald Michael's time, Cybernation, Silent Conquest, no point going up to an accountancy clerk or somebody, a bookkeeper, and saying, oh, don't worry about your job going. You could be a social media consultant. Because they just go, what's social media? Well, it's on the internet. What's the internet? Okay. So my point about this is the realm of what is possible, the new the adjacent unexplored constantly expands as we industrialize components. So it's very easy to see what's going away, very difficult to see what is becoming available. So let's start off 2016. This is roughly where we were. Runtime had become serverless, heading in that direction. That's where you need to focus. A new emerging practice. We didn't know it was going to be called FinOps, but became FinOps, and there was a new needs being built on top. Now, I'm going to get rid of a lot of the stuff on this map because I'm really only interested in starting from the runtime serverless. I don't care about operating systems and compute, and well, I do care about operating systems actually still, but much less about compute and things like Kubernetes and things like that. So I'm going to get rid of all of that stuff, and I'm going to start with the runtime, and I'm going to move emerging practice over. So this is roughly 2018. Runtime at the bottom, becoming serverless. We've got FinOps now, it's got a name. We've got coding environments. So a coding environment is like Visual Studio. It's, there's a difference between the runtime, the thing which runs the code, and our coding environment in terms of we obviously code, and then there's the application. Great. So one thing we noticed in 2018 was, of course, machine learning. Various different techniques were evolving very, very rapidly. And this led us to discussions about how we were going to have different forms of coding environment. One particular form we talked about is conversational programming environments. So what does that mean? Well, first I'm going to get rid of all the FinOps, and I'm going to simplify this map even more. Let's just start with machine learning, applications, conversational programming, coding, programming environments. So what do we mean by that? Well, it's a tool set, basically. So rather than having your traditional sort of Visual Studio type tool set where you've got, a navigator window and some text editor that you code into, maybe some search, it's, rather than ending code, it's more of a conversation with the machine. And this comes from an idea of Jonna Freeman's graphical conversation theory, which was explored in a paper by Nicholas Negroponte, which was called Architecture by Yourself. So the process of designing something is a process that can be viewed as a conversation between the minds of one or more designers. Now, that can actually occur in the head of one designer. We often talk to ourselves, for example. What conversational programming is fundamentally about is that one of the designers is the machine. So it's not just two people, it's you having a conversation with a machine, designs the system. So back in 2018, I did a number of talks about this. A good friend of mine, Alexander, went and built this and went and demonstrated AWS reInvent. So in this case, the conversation was actually verbal. So what he had was a machine which had various machine learning components built into it. And what this thing would do, this system would do, is build you a serverless application. So literally, you'd have a discussion with it. For example, I need something to track flights of airplanes. And so then it would ask you a bunch of questions, you would have a conversation with it, and it would build you a system. And this is what was demonstrated at AWS reInvent 2018. Okay, let's come forward a bit more in time to 2023. Now those conversational programming environments are obviously much more obvious. We call them things like co-pilots. So you're now increasingly with things like, you do this with chat GPT, you put in a prompt, give me some Python code for blah, 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 whatever it happens to be. And then you can ask questions, have a conversation that way. Fairly basic standard stuff. So the other thing that's happened is, of course, the machine learning components, some of them, like large language models, have very rapidly industrialized, becoming more of a commodity. And that has all the usual effects that we saw with things like cloud and serverless. You're going to have no choice because of the efficiency, increase the speed because of new practices. We don't quite know what the name of those practices will be. It's a bit like DevOps, FinOps. We didn't know they would be called that until it became that. So maybe it's ML Ops or AI Ops or whatever Ops. That's fine. Yes, it's about efficiency. Usual sort of nonsense. Consultants running around saying, oh, this AI stuff is going to reduce your IT budget. No, it's not. Once again, Jevons Paradox, you're just going to end up doing more stuff. Usual stuff. Oh, you can get rid of all your engineers. No, well, you can do, but you just have to hire them back at more expensive rates later on. And yes, you're going to get increased energy consumption. It's the same pattern every time. All right. Application tool set. We've got a different tool set going on. Coding environments, much more, the typical things you see with Visual Studio, more conversational programming environments. Underneath the tool set is language. And the language typically in most of our traditional coding tool sets is functional, declarative, whereas obviously in a conversational programming environment, it's more conversational. So it's prompts. And prompts, by the way, people might say, oh, that's not a programming language. Well, it is. Large language models, if you add memory, are Turing complete machines. So yes, it is a programming language. Now that language is written in what we call symbolic instructions. These are, you think of them as characters, text code, which has meaning. So we normally think of this as text. So when you're traditionally coding environment, your text editor, you're writing in something like, I don't know, Java, JavaScript, you're writing your symbolic instructions in text. And in fact, our large language models are trained on it. It changes the weights in the models themselves. Now that's an important point. And the reason why it's important is that we typically think of symbolic instructions as, we call it code. Well, in the world of large language models, the training data is symbolic instructions. It is code. The behavior of the AI is changed by the training data. And the reason why I mention that is lots of people talk about, open source. And they talk about open source being really, well, unfortunately, if you saw the US paper a couple of days ago, it's all about the dangers of open source and how open source is going to create Skynet or whatever, frontier AI, because these people are obviously terrorized by watching Terminator as they were young children. One of the things about open source is it's not open source unless the training data is. Because if the training data, which is used to create the model weights, is not open source, then basically the model weights are a compiled version, and you're missing a huge chunk of the symbolic instructions. But we'll come back to that, because something interesting is going on, because the symbolic instructions don't have to just be text, they can be images. And you're seeing this with what are called large multimodal models. Now, what do I mean by that? This is a slightly more complex map. This is coherent city transport. It was put together by a bunch of transport planners from Düsseldorf, Budapest, and other parts of the world. And what we're doing with this particular map is they're thinking about, what's important in city transport. There's city functions like banks and restaurants, police stations, etc. And we have ways of moving between them, roads and rail, and means of doing so. So e-scooters, drones, trains, we can walk as well. And it's through mapping this out that you realize that space, well, there's physical space, and then there's virtual space. And actually, virtual space has ways. So it's either wired or wireless, for example. And it has a mode such as internet access. And the point about that is that virtual is a transport system. Now, that might sound a daft thing to say, but as a transport system, it impacts all other transport systems. So by having this meeting and doing it virtually, we're all traveling virtual miles, except that we never bother to calculate what that actually means, but we're impacting every other transport system because normally we'd all come together in a physical space. Now, the conversation that led to that was all about the objects, their relationships, and the context in which city transport existed in. A group of my friends, some of the city planners in Budapest, went back, thought about this, and realized, it virtual impacts all other transport systems, it impacts things like congestion. And so they said, of course it does. And they produced a nice little graphic just to explain 50 people in 33 cars, 50 people in virtual spaces. Okay. And the point about this is that most of these countries have spent hundreds of billions building digital twins of cities, and most of them have not included virtual as a transport system. It's a bit like building a digital twin of a city and ignoring roads, and then it's pretty pointless. You just wasted a lot of money. All right. So if you want to get rid of congestion, encourage people to use virtual. But that's not the point of this conversation. The point of the conversation is this. When using the maps, the graphical form, we were talking about relationships, objects, and context. The code is on the left-hand side. That's the same code that produces that map. But when we have a discussion about the code, we're talking about rules and syntax and style. So is it, have we formatted this right? Have we got all the functions right? Is there an error in the code? So the very nature of our conversation changes depending upon the medium that we're actually using. And you see this in engineering departments. Because if you walk into most engineering departments, there's two conversations going on. There's one on the screen and there's one on the whiteboard. And the problem solving is done in both places. But the whiteboard is very graphical in nature. So what you've got going on at this moment is the tool set is changing. We're going from a world of, these sort of coding environments have become highly industrialized, navigator, text editor, to much more conversational programming environments. The language that we're using is changing. We're going from much more functional, declarative, more conversational, and even the medium is changing. So rather than, text, it's images. And you see this with prompts these days. You can take an image and ask it to create something from that image. So the medium that you're using is different as well. It's more conversational, it's more images, and of course the tool set needs to change as well, but we're still developing those practices. Now, why does this really matter? Why did I want to bring this all up? Well, fundamentally, the way we reason about the world around us is through language, the medium that we're using, and the tool set. That has been for an awfully long time. It's not just technology. I'm just using AI as an example of this. And it's very rare that we change all three in history. You can think of Enlightenment, for example, was a time where that and the slightly just before then was where we started to change all three. It's very rare that this happens. And so that leads me back to this whole question about open source, because I know everybody runs around saying, particularly now with this US report, you've got to have guardrails, frontier AI, very dangerous, or you'll create Skynet if you Well, first of all, most stuff is not actually open source because the symbolic instructions, the full set, i.e. the training data is not open. Okay, so it's only partially, but actually you want it all open source. If, yeah, okay, it runs a risk, I suppose. But when has obfuscation ever hidden that risk? But what we want to do is enable a new enlightenment. You want to encourage that. You should be legislating massively in favor of open sourcing it all. The alternative is we say, oh no, we'll hand over safety to a group of people. We'll create guardrails and all the rest of it. Well, that's great, but just realize that they now will define how you reason and how future generations reason about the world around them, because they will define the tool sets, the medium, and the language. So what you've done is you've created a new theocracy. So that's the problem that's facing you. I mean, there was a sensible quote long time ago: those who are willing to sacrifice freedom for security are deserving of neither. Well, that's exactly where we're going. Establishing a new theocracy. Whereas what we should be doing, I would argue, is ensuring that everything in AI, all the way down to the training data, is inspectable and open source. So I started off with the origin. So how I got into mapping, I talked about what a map is. So there is a difference between, graphs and maps. I talked about patterns you can learn. So 3 basic types. There's climactic patterns. There's about 30 of those. They're useful for anticipation of market changes and what's going to happen in the industry. There's doctrine. These are about 40 universally useful principles. They're good for how you organize yourself and structure yourself, and then you get into gameplay. There's about 100 different forms, and that's how you manipulate spaces to your favor. Most people are oblivious to this. So we talked a little bit about change. I introduced you to a couple of those patterns, things like everything evolves. We have inertia of change. You get co-evolution of practice. I talked a little bit about gameplay. I introduced you to one model, ILC. You can find all this stuff online. I just search my name, Wardley Maps. Loads of people have set up different sites, and there's about 14 books on the subject. So it's fairly easy to find. And then we talked about X marks the spot. Well, in this case, I wanted to focus on AI. We're seeing exactly the same things we saw with cloud and serverless, same patterns, same sort of consultant stories running around. It's going to save you money and get rid of your engineers, and it's a sad repetition of the past. But there is something special about this in the fact that you not only get the tool sets, but the medium and language changing all at the same time. That's extremely rare in history. Just be very, very careful that you don't create a new theocracy out of fear of change. And unfortunately, I'm seeing lots of symbols of that. So people very much going, open source is dangerous. Actually, if you want the new enlightenment, you're going to have to go down that path. Otherwise, other people will control how you reason about the space around you. And at that point, I think I've got about 8 or 9 minutes left. I thought I'd open it up to questions. This is all Creative Commons share alike. Help yourself. Oh, and I can go back and